since we're talking about what happens when we multiply feet by feet or inches by inches by inches, let's see just kind of in general what's happening here. So when we have these units, we say one-dimensional units. That's if we just had inches or feet or miles or something like that. We would say that these are one-dimensional. And you can measure one-dimensional things with a tape measure. That's a good way to measure a one-dimensional thing. And like I said, you can measure them in inches or feet or miles. Or metric. If you're talking about metric, you can go with meters or something like that. In area, when you're talking about how big a wall is, you can't generally describe the wall with just a single measurement. You can't say it's 6 feet, because I don't know, if you're telling me 6 feet, is that going to be a height, or is that a width, or is that some sort of weird combination of the two? I realize with the one exception to this might be with TVs, because you typically talk about how big a TV is, and they generally use the if it's a 32-inch TV, they're talking about the distance across there. But even that, you have to make some assumptions to be able to do that. You have to assume a certain aspect ratio. So in any case, I'm going to go ahead and say when we're talking about two-dimensional units here, we have to use two different numbers to describe them. Or when we're talking about two-dimensional space here, to get its size, we'd have to have both a length and a height, at least if it's rectangular. In general, so if this was, I don't know, 3 inches and this is 4 inches, then this particular space would be 12 square inches. The total space that's covered up by this would be 12 square inches. And you can measure it, you can write that either square inches, SQ space IN, or inches squared. Either way works to describe that particular two-dimensional area. And three-dimensional, as you might guess, now we're starting to talk about things that require 3 dimensions. So if we had, for instance, a room, I'm going with a box-shaped room. In order to describe the shape of this room, we would have to have a width. Let's call this, I don't know, 4 feet. It's a very narrow room. 8 feet high. That 4 feet's going to bother me. Let's make it 6 feet wide. Whatever, 8. 8 feet wide, 8 feet high, and let's say this distance right here is 12 feet. So maybe that's the size of a bedroom. In order to get the amount of air, for instance, that's in this room, we would need all 3 of those measurements. We would need the width, the height, and the depth, thus 3 dimensions, 3-dimensional. When we're talking about measuring 3-dimensional space, we use things like cubic inches, like that, or inches cubed, like this. Cubic feet, or feet cubed, or you can go with some specialized units that I'll talk about in a bit, gallons, liters, stuff like that. Alright, so when we're talking about these units, you can treat them in much the same way that you treat factors. And so if you're dealing with dividing, so if we have something like 24 miles, I don't know why I wrote inches, 24 miles, and we're dividing this by 1.5 hours, well, let me write it like this instead. 24 divided by 1.5, and we have miles on the top part, and we have hours on the bottom. You can see what we end up with here is miles divided by hours, which we generally abbreviate as miles per hour. So miles per, the per means division, hour. So 24 divided by 1.5, I guess I should figure out what number that is. 24 divided by 1.5 is 16. So if you're traveling 24 miles in 1.5 hours, that means your average speed there was 16 miles per hour, and you can see we got that just by dividing. We didn't have to use a special formula or anything like that. Similarly, if we have miles per hour times the number of hours, 45 miles per hour. I'm choosing to write it like this instead of like that because I want to think of it as, the miles and the hours separately, times 4 hours. Well, if we don't have a denominator, we can always think of it as being on the top part of a fraction. And you can see the hours here cancels with the hours here, and we end up with 45 times 4, which is 180. And the only units here are miles. So if we travel 45 miles per hour for 4 hours, you can see we end up with 180 miles. Alright, similarly, let's say we have 42 square yards. 42 square yards. When we're writing these as part of an equation, it it's not generally a good idea to write it SQ space YD, because that doesn't really indicate very much. Instead, it's a better idea to actually do it yards squared like this, because that, it's the same thing with inches and feet and whatnot. Divided by 6 yards. So the reason we like to do this is because now, the reason we write it like that is because then we can say, well, this is just yards times yards. We have 2 factors of this yards there. When I get rid of one of those, it's just going to cross out that square and cross out the one on the bottom. I'm essentially, this is the same as when I was working with fractions, dividing both the top and the bottom of the fraction by some number. So like here, dividing both the top and the bottom by 6, I end up with, well, I guess I could just do 42 divided by 6. It comes out evenly, whatever. We end up with 7 yards. So you can see the units there just become yards. The yards squared divided by yards. There's some cancellation. We end up with a number of yards. Similarly, if we had feet, 70 feet divided by 35 feet per second, well, I'm going to split this up. I'm going to say 70 divided by 35 because that number is nice and easy to work with. Then I'm going to have feet, and I have divided by a fraction here. And if you remember your rules for fractions, whenever you're dividing by one, you can just change that and multiplying its reciprocal. So seconds per feet. So I had feet per second. I had feet divided by feet per second. So I'm changing it into feet times second per foot. And, well, the nice thing about this is because now this foot is in the numerator, that foot is in the denominator, so they can cancel. 70 divided by 35 is 2. We end up with 2 seconds. So, kind of what's going on here, if we wanted to travel 70 feet, and you're traveling 35 feet per second, it would take you 2 seconds to travel that distance.